come in first, and then we will start. Okay. All right. Assalamualaikum and welcome back to our dynamics class for ECS 4 to 9. Today we are conducting an additional class for week 7 because we need to finish our syllabus because we have a upcoming test. Okay. All right, so this class is very important. Please let your friends know that for those who are not joining this class, to watch our pre-recorded video. Okay, because if they do not join, they won't be able to answer the test. Okay, and won't get full mark lah. Okay. All right, now, so there are three things today that we need to cover to complete our syllabus. Okay, so as I mentioned last time, for Newton's second law, okay, F equals to ma, Newton's second law. Okay, there are three types of coordinate system. Okay, the two types, one is the rectangular coordinate system. Okay, okay, and then the non-rectangular coordinate system. Okay, I'm sure you're familiar of this already because I have mentioned this many times. And then for the non-rectangular coordinate system, we have normal and tangential. Okay, and lastly, we have radial and transverse. Okay, so basically for rectangular coordinate system, this one where you resolve in the X and Y component, this one I have taught you. Have I? Yes or no, class?
Yes.
Okay.
Yes.
For the normal and tangential, we did it on our class on Tuesday. Am I right? We did one example, right?
Yes.
Okay. All right. So now we are left with one example on radial and transverse. Okay. And then I also want to add one more example. Okay. Oh no. We're gonna do on radial and transverse. Okay, that's right. Okay, that's for today's class. Okay. All right. So for radial and transverse, everybody know the radial symbol is R and the transverse is theta. Okay. All right. So we're going to go straight to this example related to radial and transverse. We're going to go to the example. So can you please copy this example? All right. Okay, good. Okay. Okay. A 0.5 kg block B slides without friction inside a slot cut in arm OA, which rotates in a vertical plane. Okay. The rod has a constant acceleration theta equals to 10 radian per second squared. Okay. Knowing that when theta equals to 45 degrees and r equals to 0.8 meters, the velocity of the block by V arm. Sorry. Yeah. The velocity of the block is 0. Okay. Determine at this instant A, the force exerted on the block by the arm. B, the relative acceleration of the block with respect to the arm. Okay, all right. So let me make this a bit smaller and draw the diagram. So let's say this is the arm. Okay. If this is the angle theta, and this is a slot, block slot B, ada slot ni. Okay, this is B. Okay, and this is A, and this is our R. Okay, can you tell me after you finish copying? Let me know when you have finished copying this question. Update me.
Diyan pwede tengah lukis.
Okay. Done?
Done, madam.
Okay. Done. Okay, so of 0.5 kg block, so there is a block slides without friction inside a slot. So this is the slot, cut in arm OA, which rotates in vertical plane. Okay, so the rod has a constant acceleration. So this is the constant acceleration. Theta equals to 10 radian per second, and knowing that theta is 45 degree and r is 0.8 meter, the velocity of the block is 0. Determine the force. So dia nak the force and the acceleration. Okay, so we need to draw the free body diagram first. So let's assume this is the free body diagram of the slot of the block B, yang block B tu, okay. Okay, for the block B, so of course you have a weight W, and of course you will have a normal force N lah. Okay, and this one will equal to the same. Okay, now for this question, it's obvious that this is a question related to radial and transverse. Okay, based on the key points given here, there's r, there's theta, so we know this is radial and transverse. It's not normal and tangential. It's not the rectangular coordinate system. Okay, and then after that, we know that this is the direction of our MAR, because our R is going this direction. So this one will be MAR, and then our theta, the theta is going like this, isn't it? The direction. So we also have theta, MA theta. Okay. So these are the two free body diagrams that you need to draw. Okay, the important thing when you read this question, you know is radial and transverse. Okay. All right. Now, let's do the solution. So what are we given? Let's have a look. We're given theta, 45 degrees. Okay, my pen is a bit thick. Okay, we're given R. So write down all the important information that is given you. You are given acceleration, theta double dot. Okay, when it's acceleration, don't forget it's theta double dot, 10 radian per second squared. If it's velocity, it will just be theta dot. And then you are given the mass equals to 0.5 kg. And what else? Okay, those are the information that you've given. And you must know W is mg. Okay, that information. So we need to use radial and transverse components to solve this problem. This is our task. We have to use radial and transverse components. Okay, so based on this question, what does it want? It wants us to calculate the force. Okay, so basically, to calculate, so basically what it wants is the force exerted on the block. So that is what it wants. So when it wants the force exerted at the block, it means we have to find the normal force. This one. Okay, so the normal force, the answer will be in newtons lah. So this is what we want to find. Okay, so how are we going to solve this problem? Okay, okay, so we need to use the concept of Newton's second law, F equals to ma. But to find um the normal force, so are we going to use F theta or Fr? So you remember that we have two. One is F theta equals to ma theta, and the other one is what? Fr equals to MAR. Okay, now let's have a look at F theta equals to MA theta. Okay, look at the free body diagram. How are you going to do that? So from the free body diagram, so let's say our direction of our theta. Okay, we know the direction of our theta. Okay, so if we want to write down the equation, we write down the equation. We have to look at the figure above. So what do we have in that direction? Can you have a look at the free body diagram? So if you notice at the free body diagram, everything what you have to do is, what do you have to do with the weight? You need to resolve in the same direction as the direction of the theta is going, right? Class, do you understand?
Yes.
Do you understand? You have to always write this. You have to always know what direction you want to follow. So if we look here, our normal force is in the same direction, so it's fine. But our weight, what do we need to do? We need to resolve it, right? So if you resolve it, will it be positive or negative?
Negative.
Negative what? W cos or sine?
Negatif W, kalau ditarik ke bawah itu W sin.
Hah?
Itu kalau kita
Cos.
gambar.
Cos.
What would it be? Sine or cos? Cos. Okay. Class, I don't have time to explain to you why cos, why sine, because this is basic. We need to speed up. Equals to m. Okay, now A theta. Do you remember the formula for A theta? I have given you previously. Do you remember? Can you please open your notebooks and tell me what is the formula for A theta? Do you remember? Remember, we have a formula for AR and then we have a formula for A theta. Do you remember, guys?
Yes, madam.
What is
sama dengan R theta tambah
okay, R double dot R squared, right? Okay, let me just, okay, and then R theta double dot plus 2
2
R theta.
Theta.
Okay,
Okay.
one dot. Okay, all right. So that is our A. So we need to write our A. So our A theta is R theta double dot plus 2 R theta. Okay, all right. Okay, so there we have that. So what is our N? So let's calculate our N. So this will be mg cos 45. And then because we bring to the other side, it's going to be plus lah. R theta double dot plus 2R theta dot, R dot, and then theta dot. Okay, now let's put in the correct information into here. So what is our mass? Our mass is in kg, 0.5 times 9.81 times cos 45 plus what is our mass? Again is 0.5. And what is our R? We have it already. What is our theta double dot? Do you know what is our theta double dot? The acceleration, right? What is it? It's given in the question.
10.
Okay, 10. Okay,
Then
10. Plus, okay, now, what is, okay, in the question, does it mention anything, if you notice in the question, it mentioned the velocity of the block is what? Have a look at the question.
Zero.
So what does it mean?
it's mean plus 0.
So what is 0? Theta dot, right? So this is 0. So because the velocity is 0, so theta dot equals to 0. Plus, do you understand? Read this question. Here it mentioned the velocity of the block is 0 because the acceleration, the theta is 45. Theta dot is the velocity, is 0. Theta double dot is the acceleration, which is 10. Okay? Understand, guys? Are you okay?
Yes.
Okay. Someone just entered. Okay. All right. Where are we? So this one will becomes plus 0. Okay. So can you give me the answer? Can you calculate for me what is the normal force? All of you have a calculator. I don't have a calculator. Can you please calculate for me?
7.47.
Yes. 7 point. Units is Newton. Okay. All right. Now, for the next question, what is it they ask? The relative acceleration of the block with respect to the arm. Okay, now they ask you the relative acceleration of the block. So FR equals to MAR. So where is the direction of the R? Okay, the direction of the R is going this way, positive. Okay, now let's look at our free body diagram. So what do we need to resolve our weight, right? So if you look at the free body diagram, if you resolve it, what will it be? W cos or W sine?
Sign.
Yes. So it will be W sine 45, but is it going to be positive or negative?
Negative.
Huh? Positive or negative? Okay,
Positive.
this positive, just now this is our block and our weight is like this. Okay, so and then when you resolve, you're going to resolve like that and like that, the same direction. Your arrow must be like this. Okay, so this one will be R, this one will be for theta. So for your R, when you resolve it, it's in the same direction with FR, right? So it will be positive. So that's why this one is positive. Understand? Okay. But when you resolve the weight due in the direction of the theta, we have assumed our theta to be positive going up. That's why your weight is negative. Please don't make that mistake. Okay, is there anything else? No, so nothing else. So it will equals to M. And what is the formula for AR? The formula for AR is R double dot minus R theta dot squared. Okay, is that the correct formula? Okay, I missed a dot here. Okay, so now, so what are we going to do? Class, what do we need to find?
Acceleration.
Okay, so they asked us to find the acceleration of the block with respect to the arm. So it means what we need to find is we need to find R double dot.
R double dot.
Yes, because R is 0.8, okay, in meters. R dot is the velocity of the arm, and then R double dot is what? Is the acceleration,
Acceleration.
but with respect to the arm. Okay, don't get confused. Okay, this one is the velocity, but with respect to the arm. Okay, so this one you need to find R double dot. So let's put in the correct information. Let's make R as our main apa? Oh, mana pergi dia?
Macam dekat belah kanan bawah.
Kanan bawah.
Tu.
Oh. Okay. Baik, you perasan. Alamak. Betul. Okay. All right. Okay, where are we? So we want to find R double dot. So this one will be mg. You can proceed and calculate for me. Okay, you don't have to manja sangat waiting for me. You can do and calculate quickly the answers. So if we put R, this one will be mg sine 45, and then divided by m, and then this one will be plus r theta dot squared. Okay, so this one you can cut. So we are left with g sine 45 degrees plus okay, and then r dot squared. Okay, so can you calculate for me? 9.81 times sin 45 plus r dot. Okay, now what is theta dot?
0.
Yes, 0. Okay, So what is the answer?
6.94 betul?
6.94.
Yes. Unit
Unit
meter per
Meter per
second
second.
squared.
Meter square.
Yes. Okay, so that is the answer. Okay, all right. Now, okay, let's go back to what we're doing here. All right, so, okay, so when we go back here, okay, oops. Okay, when you go back here, okay, you must bear in mind, so we've done this, okay. All these three types of question, it can be, the diagram can be many different types. They can have cables, okay. They can have, it can have a particle, a block, all those kind of things can also involve spring. It can be a combination of all different types. So even though in class we're only focusing on one type, like this, there in your tutorial handout, there are other types of examples. So don't rely on only one example that I show you. And then because of just this example, you can only do something is related to this one. Okay, don't do that. Okay, so what I'm trying to say is just get ready for other types of different types of diagrams that can be involved related to this type of question. Okay, what first you need to do is you need to identify what is the correct components you want to use. You have to decide on the right components that you want to use. And after you have decided the right components, then you should be fine. Okay, all right, class, do you understand what I'm trying to say? Do you get what I'm trying to say? What I'm trying to say is, for questions that are related to Newton's second law, before you begin, you have to identify which is the correct type of coordinate that you want to use. Okay, after that, the important thing is you be able to draw the correct free body diagram. And then after that, it should be simple. Okay? Okay, class? Are you okay?
Media boleh tak nak tengok yang tadi tu?
Yang tadi tu, boleh? Okay, but you didn't answer me. Are you okay?
Okay.
Okay. Yang mana yang ni?
Yep. Okay.
All right, copy this. Okay, when you're done, tell me. I want to proceed with one more example yang ada spring, because I did not go through with you an example that has a spring yet. Are we done? Lamanya, are we done?
Yes.
Yes. Lupa nak bagi tahu.
Nah. Okay, all right. Now. Okay. Now, I'm going to go back to you on work and energy method. Okay, now. Okay, work and energy method. Okay, work and energy method example. Okay, I want to remind you there are a lot of different types of questions. They can consist of weight, can consist of what? Forces, many types of forces, towing force, friction force, just example, towing force, friction force. What else? They can have tension force. Coming from what? Cables. And the other thing is what? Due to spring?
Stiffness.
Yes, spring stiffness. Okay, so there are a lot of examples that have combination of all these things, okay, which you need to look and practice. And it's not only for work energy method, it's also for impulse and momentum. It's the same thing. Okay, it's the same thing. All right, so I don't want you to rely with just because the example that I do is on weight and friction force, that is the only thing you know. And then all of a sudden, if there is a tension force in the cable, you don't know how to do it. And then when there is a spring, you do not know how to do it. But I believe you know how to do when there's a weight, the towing force or friction force or tension force cable. I'm sure you know how to do this, but I just want to include when there is a spring, because I did not give you any related examples. So can we do one example on work energy? Can we do one example on work energy that has a spring?
Yes.
And
Okay, just so that you get an idea on how to do it. Okay, do you remember what was the formula that I gave you for spring? Remember? What was it? Negative, what was it? One over two.
KS squared.
1/2
KS squared.
KS2 squared minus 1/2 KS1 squared.
Okay, all right. So let's just do one example apa with the spring, so that you understand how to do it. Because usually questions that are related to spring are questions that will you be involved with rigid body, because right now we are only focusing on particles, right? Kan? Nanti later on you'll be doing a lot of after the test lah. After the test, you'll be doing a lot of questions on rigid body, and most questions have a spring involved. So at least it's a good exposure for you now lah. Okay, let's do one question that has a spring, so that you can have an idea how to include a formula for a spring. Okay, so copy this. Okay, the platform B shown. Okay, if you guys feel tired of copying, we can always have a break and just let me know. Okay. Anyway, you're not you're not fasting, right? You should have the energy. Okay, I can hear one of your friends just joined in. Yeah, let me just. Okay. Okay. Okay, let me know after you have finished copying this diagram. Done? Okay. All right. Okay. So the platform P shown has negligible mass and is tied down so that 0. Is tied down so that the 0.4 meter long cord keeps a 1 meter long spring. So asalnya what it means is generally is 1 meter long, and then it is tied down to become how many meters? 0.4 meters. So so how long has it been compressed? 0.6 meters.
0.6.
Okay, you understand that part? Is that okay?
Yes.
Okay, now what happens? There is a 2 kilogram block. Okay, so this block is now, there is a 2 kilogram block which is placed on the platform, and it is released from rest. Okay, released from rest after the platform is pushed down. So when a 2 kilogram block is pushed down, it becomes what? It becomes from from 0 which is the original which is 0.4, it has been pushed down to 0.1, so this one becomes 0. What do you think?
0.3.
Yes, 0.3 meters. Okay, now determine the maximum height of the block rises in the air. Okay, so now what it means is after the block is taken out, maksudnya the block is taken out, he wants to know what is the maximum height dia punya spring tu akan reach, the height, the maximum height. So they ask you to calculate H. Okay, after the block is rises in the air, and then which is measured from the ground. So it wants us to calculate H. Okay, so for this question, what I want you to do is, I want you to use work and energy method to solve this problem. Okay, why we can use work energy? Because it involves displacement. Okay, it involves displacement, so we can use work energy. Okay, now, do you remember what is the formula for principal and work energy? Do you remember? Class, do you remember? Dah tak ingat dah?
Yang
Ingat,
when
ingat.
you
Hold on. Ya. Tengah kelas. Okay. So what is the principle of work energy? Work T1 plus work equals to T2. Okay, now. All right, now. Okay, now. Now, the block for T1, what is the formula? Half mv1 squared, and for T2 is half mv2 squared. Okay, now, what is the velocity for V1 and what is the velocity for V2? Now, can you tell me what is the velocity for V1? Class?
Is it 0?
Yes, it's 0. Why? Why?
No velocity.
Yila, why?
Rest.
Rest, because it is released from rest. Okay, and the next, what do you think velocity V2 is? Can you tell me what is the velocity for V2? Because V1 is 0, it starts from rest. So when it starts from rest, then we can say that T1 equals to 0. Now, can anyone tell me what is V2? What is the velocity at V2? Now, when a particle reach its maximum height, what is the velocity? I want to ask
Zero.
you. Yes, what is the velocity when a particle reaches maximum height? Okay, when the particle reaches its maximum height, the velocity is also equals to 0. So V2 is also equals to 0. Why? Because it reaches the maximum height. Due to this, T2 is also equals to 0. Okay, do you understand, guys? Okay, so it means when we write down the formula T1, work plus work equals to T2, the kinetic energy, this is kinetic energy, kinetic energy 1 and kinetic energy 2, this is 0 and this is 0. So what we need to find is what is the work. Okay, now remember there are many types of work. Can you tell me what are the types of work involved in this question?
Spring force.
Sorry? What?
Wait.
Bunyi suara motor. Anybody tengah naik motor ke? What is the work is involved in this question?
Work
Wait.
due to spring force.
Tak dengar. What? Weight and?
Spring.
And
Yes.
spring.
That's correct. So we have one is due to the weight and the other one is due to the spring. Okay, only those two are involved in this question. So let's write down the work, okay? Okay, so we have two types of work here. Okay, so first T1 equals to 0, okay, plus, okay, write down the work due to weight. Okay, now remember the formula? Negative W delta Y. Okay, that is the formula for work due to weight. And then let's write down the formula for spring. Negative 1 over 2 ks2 squared minus 1 over 2 ks1 squared. Okay, equals to 0. Now, can you tell me, guys, before we know whether the answer is positive or negative, the work due to weight, is it doing positive work or negative work? The weight. The weight, is it doing positive work or negative work? Tell me, guys. The weight, is it doing positive work or is it doing negative work?
Positive.
Negative.
The answer is
Negative.
yes, negative. Why?
Sebab ada spring kat bawah dia yang tolak blok tu ke atas.
Block to naik atas. Yes, it is doing negative work. Okay, good. That is correct. Okay, now how so basically the weight does negative work. Now let me ask you the next question. The spring. Is the spring doing positive work or is the spring doing negative work? And why?
Positif.
Yes, the spring is doing positive
Positif.
work. Why?
Sebab sifat spring tu dia memang memantul. Kalau dia tegang dia jadi negatif.
Okay, all right. Okay, good. You must be able to understand that. Okay, so let's write down. Okay, so we have the formula 0 plus, so negative W is mg. All right, now, so delta Y is what? Y2 minus Y1. Okay, let me just copy back all this formula. Okay. Okay. What is our mass? 2 times 9.81. Okay, what is our Y2? Due to, now we're talking due to weight. What do you think our Y2 is? Now, when you talk about Y2, you're talking about the weight of the height of the block, right? The final height of the block. So that will be H because that is what we want to find, guys. Y2 is H. Okay. Minus Y1. What do you think Y1 is? Okay, have a look at this diagram. Okay. Let me hold on, let me besarkan. So the maximum height H, this is what we're going to call this as Y2. So our Y1 will be when there is a weight. So this one will be our Y1. Okay, so when it has a weight is 0.3, but when it is released, we want to find out what is Y2. Okay, do you understand? So our Y2 is H and our Y1 is 0. Okay, 0.3. It's okay, guys. Don't worry. This is only just one question. You need to try other questions for you to understand more because other questions are different. Yeah. Okay. Next, let's write down the formula for stiffness. So we have 1 over 2. What is our K? What is our K? 200. Newton per meter. Okay. What is our S2? And what is our S1? Okay, look back at this diagram. What is our S2 and what is our S1?
S1 0.4, S2 0.3.
What is our S2 and what is our S1? Okay. What is the initial spring compress and what is the final spring compress? Okay, now if you notice the spring final is this is the spring. If you notice, okay, let me where's my pen? Oh, me. Okay, there I 0.6 dia first this is 0.6, dia turun 0.4 and then after that dia jadi 0.3, so dia dah compress jadi 0.7 here meters. From asal dia is 1 meter. Okay, originally it was 1 meter length long and then with the block dia turun 0.7 and without the block is 0.6. So how do you write that? Cuba have a understanding on that. So the spring compress berapa banyak? Kan the spring yes. Okay, good. So the spring asalnya spring dia initially compress 0.7 and without without the block dia only 0.6 kan. Okay, so
Yes.
Okay, this question is quite difficult. Usually it's not that difficult. It's straightforward. We put the K. Okay, but however, it's good to try this one difficult question first lah. Okay, so from here, there's only one unknown, which is H. So you can find and tell me what is H. You got the answer?
0.9 cm.
Betul. Meters, Okay. Good. Okay, now. Okay. So now you understand that about that. So is good. Okay, now what I want to highlight here. Okay, so basically work energy method and impulse and momentum. Okay, there are a lot of different types of questions, right? Okay, I want you to bear in mind that for work energy and impulse or momentum, they also can be related to the coordinate system, the rectangular one, the rectangular coordinate system. It can also be the normal and tangential, and also can be radial and transverse. Okay, all right. So it means when you get a question, our step one, you must identify which is the correct coordinate system. Maksudnya this is the step when you want to solve questions that is related to dynamic you must identify which is the correct coordinate system. And then after that, step 2, you identify method or principle you want to use, method or principle to use. So basically, for identify the correct coordinate system, it can be what? Curvilinear. It can also be rectilinear. Am I right? And then when you want to identify the method, you can use what? You can use the basic kinematic equations. You can use what else you can use? You can use the basic kinematic equation with constant acceleration. This one we have learned earlier part, constant acceleration. You can use what? Newton's second law. You can also use what? What we learn, work energy. And one more, principle of linear and impulse. Okay, because this one I really want you to understand, because when you get a question, whatever question in dynamics, you have to identify, okay, which is the correct coordinate system? Is this a question curvilinear or rectilinear? Okay, so if it's curvilinear, you know there are other methods. If it's rectilinear, you know what other type of questions, isn't it? Remember, if curvilinear, we also have what? Free fall motion. If rectilinear, we have what? Free fall motion. And then we have what? For curvilinear, we also have what? Motion of projectile. Okay, so there are a lot of things involved here, but as long as you understand what method to use to solve the problem, you can solve any dynamic question. So when I mention motion of projectile, free fall motion, basic kinematic equation, constant acceleration, Newton's second law, work energy, principle of linear impulse and momentum, do you have a problem? You understand those things. We have learned it, right? But when you get the dynamic question, you have to identify what method you want to use. It seems like, okay, for example, let me open the assignment. Okay. So let's say this is the assignment, right? You have to decide, oh, what rectangle, what type of coordinate system is this problem involved? Okay, obviously when you look, okay, this must be the rectangular coordinate system. Okay, am I gonna use if you look at the keyword, okay, what method I want to use? Do you want to solve it using Newton's second law, or you want to use it using the basic kinematic equation? So you have to decide. And then when you look at this question, oh, for this question, what am I going to use? Okay, you see the clue, either AT. What is AT? Which keyword uses AT? ATNN. Okay, so you have to identify. When you look at this question, oh, you look at this question, you dah panic dah. Tapi jangan panic. What can you see? Ada radius, ada velocity. You have to know what is the best method to solve this question. Okay, all right. Okay, but don't worry. It will be fine. You just need a lot of practice. It should be fine. Okay, all right. Now, can we proceed? Are you okay, guys? Now, can we proceed?
Okay, boleh.
Madam, boleh tak tengok tadi yang Madam tulis step 2 tu?
Ni.
Sekejap je. Okay, thank you.
Ini ada lagi tau, rectangular coordinate system. Tapi I dah banyak kali sebut lah. Yang curvilinear ni kan non-rectangular coordinate. Okay. Right. Okay. Now we are going to go to topic chapter 3, because topic chapter 3 is in your test. Okay. Can you tell me what is the title of topic chapter 3? Can you tell me what is the title of topic chapter 3 in your lesson plan?
Kinematics of rigid bodies.
Yes, okay. So topic 3 is kinematics of rigid body. Now, before this, we have been doing questions that is only related to particles. Now we're doing questions related to rigid body, but now we're doing kinematics. Can you remember what is the difference between kinematics and kinetics? Kinematics is related to the what? Geometric aspect, remember? Which is S, V, A, and T. Yes. Okay, now, do you know what is the difference between particle and rigid body?
Yes.
What? What's the difference? Okay, a rigid body is idealization of a body that does not deform and change shape. It means it does not deform or change shape. Okay, all right. So now when we go to topic 3 until 4, 5, 6, we're only going to deal with rigid body only. We're not going to do any questions related to particles anymore. Okay, all right. Now, okay. So basically the difference between rigid body and particle, right now when we talk about rigid body, it has uh internal structure components. Okay, before this a particle, let's say it's a big what aeroplane, we only, even though it's as big as an aeroplane or as big as a speedboat, we consider it as a particle, like a small dot. Okay, just moving like that. But now when we talk about rigid body, there are all other internal forces involved lah, all other internal parts lah. Okay, so now we're gonna do questions that are related to rigid body, but then we're gonna focus on kinematics. Okay, don't worry, this topic is easy. Usually I believe that for your test you can score full mark. Boleh tak? I'm not kidding, yeah. I expect you get full mark for this question if it comes in the test.
Boleh, insyaAllah.
Okay, now. Okay. All right. Okay. Now. Okay. Now, when we talk about rigid body and kinematics, kita have to go back to our basic kinematic equation. Okay. Now, this one you have learned in the earlier topics, dia macam revision. Can you tell me the basic kinematic equation? V yang with constant acceleration, do you remember? V equals to? V
V
naught
equals to V naught
plus ACT plus AT.
Okay, lagi?
S equal to S naught plus V naught T plus half AT square.
Lagi?
V square equal to V naught square plus 2A S minus S naught.
Okay, this is the basic kinematic with constant acceleration. If you remember, basic kinematic equation with what? Constant acceleration. Okay. Apa lagi formula you belajar? Yang dulu, yang lagi sebelum tu. Lagi? V equals to
DT.
dt.
D over T.
d over t, v equals to ds over
dt.
a equals to
dv
v.
over dt.
One more, a ds equals to
ds.
v d v. Remember that? Okay, now. Okay, so these are the this question is what? The basic kinematic equation, Okay. Now, when we do rigid body, we're going to use the same equation, but there is a change. Okay. Now, the change is that you need to understand is right now, S is what? Position, right? We're going to change S to theta. Okay, S is position. We have to change to theta. Okay, what else? What else do you think? Velocity, we have to change to omega. Okay, let me write this. This is theta. This is what you call omega. Okay, velocity becomes, the symbol becomes omega. Okay, wait. Tak ada space lah. Let me just write somewhere big here. Okay. Okay. Now, this one is kinematics. Okay. Wait. Let me make you understand ya. Sekarang ni this is particles and this is rigid body Simbol dia bertukar tapi formula dia sama Okay, just bear with me. I need you to understand this. Okay, before this position kita guna simbol apa? S, right? Now, when you change the itu rigid body, it becomes theta. And what is the unit for theta?
Radian.
Radian. Okay, good. Now, before this in particle, for velocity, you use the symbol apa? V. Now, when you want to change to rigid body, you have to use the symbol, this one. This is what you call omega. And this is what you call angular velocity. Okay. And then previously in particle, you use the for acceleration, you use the symbol apa? A, right?
A.
Okay. When you change to rigid body, you have to use the symbol alpha. So this will be called angular
Acceleration.
acceleration. Okay. Is that okay? Now, so it will be the same, but we have to change this. Okay, now let's change this. Let's use a different color so that you understand. But it's the same concept. It's just that how we define it is different. So what will it be? So V will be what when we change this?
Alpha.
Omega.
Omega.
Omega equals to omega
Omega
naught
naught
plus
plus alpha t.
okay, do you understand guys?
Yes.
Okay, so jangan risau, subjek rigid body ni dia senang, dia replicate balik apa yang kita dah belajar sebelum ni, tapi cuma kita kena change the symbol and then the definition also change. Before this we call velocity. Right now omega ni yang bentuk macam W ni kita panggil angular velocity. Okay? Boleh? Alright. So cuba you change all the others. So this one S dia jadi theta equals to
Theta naught
plus
omega naught t
plus
half alpha t square.
Okay, sama je. Okay, this one becomes omega squared equals to omega naught squared plus 2
alpha
and then S minus
minus
theta
theta
naught. Okay. Sama juga dengan ni. So this one becomes omega d theta over
dt.
alpha jadi d
D
omega over
dt.
dt. And then last kali, this one is for this one. And then last kali,
Alpha
alpha
ds.
ah
D d theta omega d omega.
Okay, good. Good. Okay, now, so this topic is easy, as I said, and you should be able to score full mark, if it comes out in the test, Okay, I want you to score full mark, because it's the same thing. It's not difficult. It's just that we have to change the symbol to theta, omega, and alpha. Okay, all right. And then there is three other new formulas that I would like to introduce to you. Okay, this is a new formula. I put a star. Okay, is velocity. Okay, even though we are in rigid body, they also can ask what is the velocity. Velocity will equal to omega times r. R is radius. Okay, and then if they ask you the normal acceleration, okay, this is other formula. Okay, let me just explain to you the formulas, and then when we start doing the question, you will see how we're going to use it. Normal acceleration, the symbol is an r omega squared, and then one more formula, the tangential acceleration, at equals to r alpha. So what I'm trying to say, in dynamics, for this topic, kinetic of rigid body, they can still ask you what is the velocity, what is the normal acceleration, and they still can ask you what is the tangential acceleration. But because it's rigid body, dia equals to omega times r omega squared, dan r alpha. Okay, so these are three new formulas that you need to memorize and put in your notebook lah, if you need to use it. Okay, now, are you guys okay?
Okay.
All right, you guys okay. Now, let's start with a very simple, basic question that is um, related to dynamics. Okay, but before that, let me just hold on. Let me um just explain a little bit about the theory. Okay. Okay. Now, so when
Madam,
yeah,
sorry, yang formula atas ni kan yang V sama dengan omega times radian kah? Ke apa?
radius r
Oh,
r.
radius.
Ha.
Oh, okay.
Okay. Okay. Oops, let me just go up here. Okay. All right. Okay, now. Okay, when you talk about rigid body, dia rigid body ni dia punya movement, dia, let's say this is our rigid body, selalunya in questions related to rigid body, if you open the textbook or the slide notes, dia suka represent the rigid body macam dalam bentuk kacang macam ni. Alah, tak jadi kacang pula. Macam ni. So rigid body dia boleh move dalam bentuk many types of forms. Dia boleh move like this from one position there to this other position. This is, wait, susah lah nak lukis kacang. I lukis bulat boleh?
Boleh.
Boleh you lukis kacang. The reason why dia lukis gambar kacang is because dia nak tunjuk the rigid body can be any type of shape lah. So if you look at this thing, this path is what you call path of rectilinear translation. Okay. Rectilinear, the meaning is moving in a straight line. Translation, dia move from this position to the other position. Okay. So a rigid body can also move curvilinear. Dia boleh juga move in a curvilinear form. So this path is what you call path of curvilinear, tapi translation. Maksudnya dia translate from this position to this other position tapi curvilinear. Same, this similar of what we learned in the earlier topic, okay? And these terms you should be familiar because kita dah belajar rectilinear is what? Do you remember what is rectilinear? Moving in what?
Moving in straight line.
Okay, in a straight line. And do you understand what is translation means? Translation means the original what it means is the original dia punya body of the rigid body, dia remain parallel to the movement. Maksudnya dia tak ada berubah, dia tak change apa? The rigid body dia tak change shape. Dia translate macam you letak kat position lain, you push it to another position. Okay? Alright, boleh tak guys? Okay. Lepas boleh?
Boleh.
Boleh, okay. The other thing, let's say you have another rigid body, apa yang berlaku ialah dia boleh rotate. Tahu tak pusing macam gasing tu. So what it means, it can rotation about a fixed axis. Contohnya macam gasing. Let's say you have a rigid body and then dia pusing rotate. So the rotation tu berlaku where a fixed axis. Okay? Boleh? Boleh tak guys? Okay, mungkin I kena.
Boleh, madam.
Yeah. Okay, and then one more. This one is what you call plane motion. Okay. Okay, plane motion ni pula, dia combination tak cantik lah. Sekejap.
Madam, saya minta diri dulu
Okay, ni Zuhair
Zuhairi.
Zuhairi Okay. Zuhairi,
Okay.
boleh tak nanti you continue tengok recorded video
Recording.
untuk ni
Okay.
pas masuk test
Okay.
Okay.
Thank you, madam.
Alright, take care. Okay. Alright, so
Assalamualaikum.
salam. Okay, so general plane motion ni, you boleh agak tak what is it? General plane motion ni pula adalah combination apa? Combination, translation, and rotation. Okay. So, now, very simple jangan susah hati sangat subjek rigid body ni. Jangan susah hati sangat topik rigid body ni. It's very easy. Rigid body ni you akan tengok soalan ni dia move translate saja. Dia translate from one position to other position. Tapi dia translate in a straight line. Lepas tu another type of question, dia translate juga tapi dia tak translate in a straight line. Dia translate in a curve line. Nampak ni, curvilinear. So there is another one, dia rotate tapi dia rotate at a fixed axis. Dia tak move, dia tak translate, dia tak change position tapi dia rotate dekat position yang sama. Okay, and then a general plane motion pula dia combination of translate and rotation. Okay tak guys? Is I try my best to explain the easiest way, but don't worry, once we do the example, you akan nampak lah. As long as you faham the different types of motion. Are you okay? So ada 4 types of motion ni A, ni B, ni C, ni D. Are you okay guys?
Okay.
Okay, jangan stres. Subjek ni best. Okay, subjek ni dia dah jadi senang. Okay, because kita buat balik benda yang sama yang kita dah belajar sebelum ni, cuma kita tukar simbol dan cuma perbezaan kalau you perasan, dia ada rotation. Previously, kalau kita buat apa tu, particles, dia tak rotate. Dia hanya move rectilinear dengan curvilinear saja. Okay, boleh? Okay, jom kita try buat a few questions so that you can understand better, boleh?
Boleh.
Are you okay? Do you want rest? Sebab I know it's already 2 o'clock.
Madam, take 5 boleh.
Okay, boleh. Pergi take 5. For those that want to go to the toilet, can go to the toilet. And want to drink water, wash your face, can. While doing so, I will copy the question for you. And you copy? Boleh?
Boleh madam.
Okay, alright. Okay. Okay, pergi take 5. Pergi take 5. Okay. Sikit lagi. Okay. Jangan stres sikit lagi
Take
Okay.
5 dulu ke atau salin soalan dulu?
Tak kisah, you can take 5, you can salin soalan, but once you have taken 5 minutes and you have completed copying the question, we can begin.
Okay, madam. Thank you.
Okay. Okay, let me know when you are finished with your 5 minutes break and your finish copying this question.
On the way copy, madam.
Okay.
Madam, yang radial per S2 tak ada kuasa. S2
Yang mana?
yang kat soalan tu.
Yang kat soalan ni, the angular velocity of the disk is defined by Omega equals to radian per second.
Radian per second tu tak ada kuasa 2 ke apa?
Okay, yang tanya ni, omega tu apa sebelum ni? Represent apa?
Omega represent velocity.
So kalau velocity, okay, kalau sebelum ni position unit dia apa? Meter, velocity meter per second, acceleration apa? Meter per second squared kan? Okay, so
Ya.
theta ialah radian, so angular velocity akan jadi radian per second, angular acceleration akan jadi radian per second squared. Okay?
Okay, baik.
Okay, sorry, saya lupa nak inform you the units. Okay, so just theta adalah radian, omega adalah velocity, tapi kita namakan dia angular velocity, so radian per second. Alpha adalah acceleration, kita namakan dia angular acceleration, unit dia adalah radian per second squared. Okay? Okay, tapi dalam rigid body dia boleh tanya velocity juga. So velocity unit dia meter per second, yang ni meter per second squared, tangential acceleration pun meter per second squared. Okay, boleh? Boleh tak?
Okay, betul. Okay.
Okay. Okay, I'm just relaxing now. You tell me when you are done, Okay, I hope everyone is okay, If any one of you lost, blank, apa? You can always PM me and Dr. Ilya and tell us what is your problem and we can help you, But we don't want to hear you have the problem after the test is finished. It should be before, Before you have the test, before you submit your assignment. Okay. Hold on,
Sorry, sebab ni pecah, takut tak masuk kitchen. Jatuh. Pecah. Kan? Sebab ni bahaya. Kalau tak, I tunggu je. Apa, tangan I dah okey? Angkat tu. I have what's wrong? Pecah everywhere in the kitchen, so I don't want.
Apa yang pecah? Sekejap. Let me, I tengah kelas, let me just mute ni.
Mangkuk pecah.
Yalah.
So kids coming in and out, I takut. Ada sapu, but then dia kata better. I'm beli RM20 online. Tak, ya ibunya warna merah ke? Azia tak ada apa-apa tu ibu. Ya ke? Ya. Tidak.
Okay, I'm still waiting. Take your time. Okay.
I'm done.
Okay, you're done. Yang lain boleh? Dah 5 minutes ke?
Dah, madam.
Okay, alright. Don't worry. I want you to get 100 marks for this last topic because I expect the question is easy and you can do it. Okay, now angular velocity of the disk is defined by omega equals to 5t squared plus 2 radian per second, where t is in seconds. Determine the magnitude of the velocity and the acceleration of point A. All right, now when you read this question, determine the magnitude of the velocity and the acceleration, it means it wants us to find what is V and what is A. When the disk is T equals to 0.5 second. Okay, now, so when you read this question, let's go back to the formula. It means it asks us to find V. Now, what is the equation for V? V equals to
Omega R.
Omega times r. And what is the formula for acceleration? Now, how do you decide? You want to use the normal acceleration or the tangential acceleration? How do you decide? Yes, good.
Tangential.
Good. I think you understand now. You're very smart. Okay, you have to use for this question. It asks you the acceleration. it means you have to find both. I think you forgot already. Good. Remember this?
Yes. Total acceleration.
Okay. If they said they want tangential acceleration only, then only you find AT. If they ask the normal acceleration, then only you find EN. But if they ask you to find the acceleration, it means you have to find the square root of AT squared plus AN squared. Okay. Now, so the angular velocity of the disk is defined by omega. Now, for this question, is there any for this question, only rotation is happening. It's there's no translation. It means this rigid body is not moving to another position. It's not translating. It's only rotating. They're rotating. Okay, now. So for this question, we need to find V. V equals to omega times R. Okay, how are you going to find omega? Can you please tell me? Omega is given, right? Omega is given as 5t squared plus 2. But what we need to do is we need to replace t with 0.5 second. Can you please replace t with 0.5 second into the equation? Okay, can you tell me what you get? Huh?
3.25
Okay, what is the unit?
meter second.
Hi.
Radian per
Radian. Omega kan?
Radian what?
Radian
Per second lah.
per second.
Okay,
So
all right.
velocity.
Okay. All right. So we have omega. Do we have R?
0.8.
Okay, so very easy. Okay, so V equals to omega times R. So it's just 3.25 times 0.8. What is the answer?
2.6.
Okay, what is the unit?
Radian per second.
No.
Meter per second.
Meter per second. Okay, next. Next, you need to find AT and AN. Okay, how do you find AT and AN? Okay, what is this? What is the formula for AT?
R alpha.
R alpha. Okay, quickly do. This is easy, 0.8 times R alpha. Oh, sorry. Yeah, you're correct. AT equals to R alpha. Okay. Oh, but do we have alpha? We don't have alpha. We have to find alpha. Am I right?
Yeah.
Okay, but we can find, we find AN first, easy. AN is R omega squared. So R is 0.8 times omega. We have found omega just now. What was our omega? 3.25 squared. Can you find me what is it, AN? Zero 0.8 times omega squared. What is the answer?
2.6.
Apa?
8.45.
Unit meter per second squared. Okay, now
Second square.
tell me guys, how are you going to get alpha?
Differentiate.
Using basic.
Differentiate what?
Differentiate omega. Omega 5t square.
Yes, that's correct. Okay, so it's the same concept like last time. Remember, position, if you want to find velocity, and then if you want to find acceleration, if you from position to velocity, you need to what? Differentiate. Remember? From velocity to acceleration, you need to differentiate. But however, if you want to find from acceleration to velocity, you will do what? Integrate. And then from velocity to position, you will integrate. So it will be the same thing. So let's say the angle, which is the theta, and then you have angular what? Velocity, and then you have what? Angular acceleration. Is the same concept. If you want to go to here, you need to differentiate. From angular velocity to angular acceleration, you have to differentiate. However, from angular acceleration to angular velocity, you need to integrate. It's the same concept. Do you understand, guys?
Yes,
Okay,
madam.
okay, so it's not something new, it's something basic that we know. So right now, you have what do we have? We have, okay, this is omega, this is alpha, this is theta. So we want to find alpha. What we need to do? You need to differentiate omega. Okay, what is our omega? So our omega is 5t squared plus 2. So you need to differentiate that. So alpha equals to d omega over dt. So can you please differentiate this? What do you get? 10t, right?
20.
10t. Okay. So 10 times t. T is what?
5.
T is 0.5. So 5. So if we want to find an, is just r. No, sorry. We don't. We want to find what? ATN.
80.
So we want to find AT is just R alpha. So it will be R 0.8 times alpha. What is our alpha?
5.
5. So 0.8 times 5 berapa?
4.
For what?
4 meter per second square.
Okay. So now if you want to find the acceleration, how do you find the acceleration?
Square root.
Okay. So A equals to square root AN squared plus AT squared. Can you give me the answer?
$9.35.
Yes. Okay. Senang tak?
Senang.
Yes. Okay, so it's going to be that easy, for you? Okay, hold on. Let's try another question. Can we try another question? To see and check whether you understand what I'm
Okay.
trying to teach you. Okay. Now. Okay. Okay.
What time finish?
Belum ni. Okay, sikit lagi. This is our last question, eh? Okay, can we do this last question?
Sure.
Okay. Okay. Let me know when you finish copying it.
Done.
Done. Okay, now. The disc is originally rotating at omega naught. Okay, you must be very vigilant and careful. This is not omega. This is what? Kadang-kadang student salah nampak. This is omega naught. Omega naught means the initial angular velocity. Sebab dia omega naught. Initial angular velocity. Okay. Dia macam V naught. Okay. It is subjected to a constant angular acceleration alpha 20 radian per second square or to per square ni. Determine the magnitude of the velocity and the n and t component of acceleration. So for this question, what they want you to find is they ask you to find the velocity. So you just use V equals to R omega to find, and then they ask you to find AN and AT. Okay. The next question, determine the magnitude of the velocity and at component of point B pula. Same, they ask you to find V again. And they ask you to find AN and AT. But when the T undergoes two revolution. Okay, this is something new, two revolution. How are we going to answer when they are the dual revolution? Okay, do you know what is one revolution? Class? Do you know what is one revolution?
360 degree.
One revolution is 2 pi. Have you heard of that?
Yes.
Okay. So one rev is 2 pi. So when you need to find two revolutions, it means 2 times 2 pi equals to 4 pi. And 4 pi is, it means the theta is 4 pi. Okay. All right. Now let's do this question together and then we're finished. Okay, guys. All right. Now, so very easy. First question. V equals to R omega. Okay. I boleh naikkan ni. I can pull this up. You have copied the question. So V equals to R omega. Okay. What is our R? For question number A, dia suruh consider point A. So for question number A, our R is what? 0.5 or 0.4?
0.5.
Okay, so our R is 0.5. But what is our omega? We do not have omega. We only have omega naught. So how are we going to find omega? Okay, let's look back at the formulas. Now, let's look back at the formula. Oh, where's the formula? Here. I think I have to pakai mouse lah. Okay, let's look back at the formula. Okay, now. Okay, so we have omega naught, but we want to find omega. Now, which formula you want to use? Formula number 1, 2, or 3?
1.
Yes, formula number 1. See, means you have to use the basic formula that you've learned previously. Okay. Okay. Sekejap Kenapa this tak work I punya mouse ni. A bit difficult. Okay, so Allah hilang dah pen dah. Okay. Let me just enlarge this. Okay, tolong kira I think you understand what to do. Okay, where are we? So it means we have to find omega first. So omega, oops. It means omega equals to omega naught plus alpha CT. So our omega naught is 12. Do you have alpha?
20.
Yes, 20. Do you have T?
2.
2. So what is the answer? 52, right? 52.
52.
Jangan lupa radian per second. Okay, so you just multiply 0.5 times 52. So 0.5 times 52 dapat berapa?
26 meter per second.
Yes, 26 meter per second. So you're done. Next, you need to find AN, which is R omega squared, and then AT, which is R alpha. So for this one, it's very easy. It's just 0.5 times 52 squared, and this one is 0.5 times 20. Okay, so what you get, this one, I think you get 1352 meter per second squared, and this one you get 10 meter per second squared. Okay, senang je. Okay, we go to question, can we proceed?
Yeah.
Okay, now question number B. Okay, determine the magnitude of the velocity and the NNT component of point B when the disk undergo 2 revolution. Okay, now, so because dia kata dia nak when T undergoes 2 revolution, so remember I've told you 1 revolution equals to 2 pi. So if 2 revolution, it will be what? 2 times 2 pi. It becomes 4 pi. Okay, so this will be your theta because this one is in unit radians. So your theta is 4 pi radian. So for this, you have to find a new W, a new because you need to find the velocity. Velocity equals to R omega, but your omega will have to depend on the formula that use theta equals to 4 pi. So for that, you have to find using this formula. Omega squared equals to omega naught plus 2 alpha theta minus theta naught. Okay, so omega squared equals to omega naught. Omega naught, do we have omega naught? Class? Berapa? 12. Okay. Do we have alpha?
20.
20. Now, do we have theta?
4 pi.
Yes, 4 pi. And because it starts and rotate from initial, so our theta naught is usually 0 lah. Okay? So then we can find omega. Can you quickly find for me what is omega? So this is 144 plus 2 times 20, 40 times 4, 160 pi. So what is our omega? That's square root, kena square root. What do you get? Oops. What do you get? Can you give me the answer for omega?
$25.43.
Dah kali pi dah?
25.79.
25.43 madam.
Okay, radian per second. So then you can just find V equals to R omega. Your R this time is 0.4 because you are considering point B. So V equals to R omega is 0.4 times 25.43. Please don't make careless mistakes in using your calculator, my dear. I cannot help you during your test if you make mistake in putting the value in the calculator. So this one you get 258.67 meter per second squared. And then you have AT equals to R alpha squared 0.4 times 20 equals to 8 meter per second squared. So that easy, yeah? Okay, now, okay, that's the end for rigid body. However, actually there is one example in the textbook that I want to go through. However, I think it's enough for today. It's 2 hours already. We start at 12:30. Now it's already 2:30, so we should stop now. I don't want to proceed another hour. So basically the other example yang ada translation and rotation, yang ada plane motion, what I'll do is I will do a recorded video of one example and then you just watch it later when you are free. Is that okay?
Sure.
Okay.
Sure. Okay, good. All right, now, just last recap. Okay. Just last recap. So we have 3 chapters in ours that will be in the test. Test 1 ada chapter apa? 1, 2, 3. Do you remember what is the title of chapter 1?
Kinematics.
Kinematic of particles.
Okay, kinematics of
Particle.
particles. Do you remember what is the title for chapter 2?
Kinetic of motion.
Kinetics,
Kinetics of particles.
particles.
Kinetic of particle.
And then
Newton
one more,
and linear momentum. Rigid body.
Kinematics of rigid body.
of rigid body. Okay, so remember kinetics of particle, basically what I taught you was what? I taught you about rectilinear. Remember? Rectilinear and curvilinear. Remember?
Linear.
Okay, and then remember what we use for rectilinear, we use what? Basic kinematic equation and equation with constant acceleration, remember?
Yes.
And then for curvilinear, what did we learn? We learned about motion of
Motion of projectile.
projectile. Okay, good. So if you have covered that, you understand all that, then you are good. Okay, now next we are involving kinetics of particle. In kinetics of particle, remember what we did? We use Newton second law. Remember?
Yes.
Yes, Newton's second law. Okay, and because Newton's second law, it involves forces, and then we also learn about work energy and
Impulse and momentum.
impulse and momentum.
Momentum.
Okay, and kinematic of rigid body is the same, yeah. However, now we are doing rigid body. So the difference is it involves apa? Translation and
Rotation.
rotation. Okay. Actually, you can even put it in more details, all these things. But however, just understand the overall picture. You understand, right? I hope all of you understand that what is consists in topic 1 to 3. So whatever question you get, you can do. Boleh?
Boleh.
Boleh. I rasa boleh.
InsyaAllah.
InsyaAllah boleh. Boleh. So all these topic will be in the test. Okay? Will be in the test. However, macam topik kinematics of particles ni, dia banyak. If you notice, dia banyak kan? There are a lot of types kan? Because it was the first one. But then, if you notice when we do kinematic of rigid body, we are doing the same thing. But of course, the symbol is different. Okay. So, it's a repetitive of what we've learned before. Nanti later on bila you buat kinetic of rigid body, we're going to do the same thing macam chapter number 2, but of course the symbol will be different. Okay. And of course dalam topik kinetics of rigid body akan ada Newton's second law, work energy again and impulse again. Okay. But don't worry, itu later lah, topic 4, 5, 6. Okay, so any other questions that you would like to ask me? So what I'll do is, I have one more type of question on kinematic of rigid body, yang ada rotation and translation. That one you tengok recorded video sajalah, boleh? But what is important, you understand this. You understand the basic on how to solve problems related to kinematics of rigid body. You know that apa? This one lah yang kita go through ni. You know about this whole thing here. Yang penting this whole thing here. You understand there are 4 types of motion. Dia ada apa, path of rectilinear translation, path of curvilinear translation, rotation about a fixed axis, ataupun general plane motion. Kalau general plane motion, the combination lah, translation and rotation. And then you understand that these are the formulas that is involved in this topic, and you understand the units. That is fine. Okay. Anything else you would like to ask before we stop?
Madam,
Mm-hmm.
untuk soalan yang tadi tu, yang apa tu, yang revolution tu,
Mm-hmm.
itu memang kita kena guna formula omega kuasa 2 tu kah?
Okay, why? Because why you need to use that formula is because that question dia suruh you cari apa, the question was, if I read back the question dia tanya apa tadi? Determine the velocity and acceleration when it undergoes 2 revolution. So it means you have to use theta equals to 4 pi to find the new omega, because it's a different question.
Okay.
Because the question dia cakap kat you, find velocity kan. Velocity ialah R times omega kan.
Ya, betul.
Tapi omega tu you tak boleh pakai omega from question A. You kena find a new omega based on theta yang dia bagi. So that's why you cari pakai formula number 3 ni. Nampak tak?
Nampak.
Because you have to incorporate your theta tadi. Your theta was what?
4 pi itu kan?
4 pi. So you have to read the question. Sebab itu ada 2, ada A, ada B. Yang A tadi lain. Yang A tu lain. Okay?
Oh, okay, faham.
Dia tak interrelated, dia different. Okay.
Thank you,
Alright.
madam.
Yang penting you jangan tersilap omega naught. You jangan silap units. Okay, but however, I think question chapter 3 will be simple and easy lah, because kita dah go through a lot in dynamic kan. By the time nak buat rigid body ni jadi senang. The difficult part was the chapter 1, nak make you understand the subject tu je. Okay, any other questions you would like to ask? So can you please, when the recorded video is ready, can you please watch on the example on rigid body? Just one more example je.
Boleh, insyaAllah.
Boleh Okay. Alright, so good luck for your test. Okay, you can start preparing, trying the tutorial and everything lah. And can ask me questions if you have problems. And Dr. Ilya also is here, can help. We will work together. Okay, and help you guys. Okay, anything else before I stop?